delete everything and start from the beginning, right? So when you launch FreeCAD, okay, right, share my screen. Okay, so when you start FreeCAD, my default position is start with part design. Okay, and then from part design, you go and create a sketch. Okay, that's the create sketch icon. Create a sketch, and it will ask you on which plane you want to put your sketch. Select X and Y. Okay, click OK. And now you are on the X and Y plane. Here you can draw your whatever shape that you want. So if you want to create a square patch, we draw a square on that plane. Okay, it doesn't matter that the shape is not square at the moment, because FreeCAD is a parametric modeling software program, which means you can define all measurements. Okay. In this case, we want to say what defines a square is that all sides are equal in length, right? So we select the top and the right line, and we press E for equal on the keyboard. Okay, now you see if I try to resize the square, the width and the height will scale together. It's a square. You don't need to define the other sides because it's already defined by the fact that this line is vertical. The line on the left is vertical. The line on the right is also vertical. And then lines on the top and the bottom, they are both horizontal. So those will already take care of the dimensions or the fact that this will be a square. Then the next thing I want to do is I want to fix the square on the canvas. I don't want it to be able to kind of move randomly around. I want to fix it in the center. So the easiest way to do that is to create a symmetry. So I click that top right corner, press Control on the keyboard. Is there a way to let this key press show up on the screen? So I click that top right corner, bottom left corner, and then click the center of symmetry or the line of symmetry, which is the dot in the center. Click that and press S on the keyboard for symmetry. Okay. Now, if I try to move the square, I find that it doesn't move. It's always centered around the center of the square of that canvas, but it scales as a square, right? The square becomes larger or smaller. So if I look on the left-hand side here, it tells me I've got 1 degree of freedom. That means there's still one parameter to define before this square can be fixed. Yeah. What is that parameter? That is the length of the side of the square. So how big do you want this patch to be? I'll say probably 15 millimeters, okay? And you're working in millimeters here. You can see down here, you're working in millimeters. So we want to define this line to be 15 millimeters. How do you do that? I'm sure there's an icon somewhere that you can click, but I work best with the keyboard because I kind of memorize all the shortcuts. E for equal, S for symmetry, right? It's quite intuitive once you get used to it. And I know that for length, the horizontal length, the keyboard shortcut for it is L. If you press L, select that line first, then press L on the keyboard and type 15. That will make that 15 millimeters. And now you see the shape is turned green. And on the left-hand side here, where they had, it said 1 degree of freedom. Now it says fully constrained. Now this is fixed, right? There's no other way to draw this square. You've defined everything that's possible to define, okay? That's what you want to get to every step of the way. Any shape that you add, any shape that you draw, you want to get to this point where it says fully constrained, okay? So now you've got basically the basis of a patch, a square patch. What it doesn't have is it doesn't have thickness, right? Now you're still in the Sketcher workbench. So whenever you have these kind of items show up on the left-hand side, you are in a specific function. So these functions or these parameters or this information is specific to the sketch function. Yeah. So you need to exit this function first, close. Whenever there's a close function, close it when you're done. So you return to this view where you have the square lying in the XY plane. It doesn't look like a square now because this is the isometric view. Is this view here? Okay. If you can rotate the view, you can go to look at it at the front. It's flat from the front. If you look at it from the top, you should see a square. Yeah. So you're actually navigating a 3D space. Do you follow?
Yeah.
Yeah. Another clue for you is also this thing that looks like a dice here on the top right-hand corner. This one shows that you're looking at the top. You can actually click this and rotate it. Yeah, you can click that corner and say, I want to look at it from that corner. You can do all those things. The default view for me, the best one that is like a point of reference is isometric. I like to return to this view all the time when you're looking at a 3D object. Now, this doesn't look very good because it's not 3D yet. What we want to do is we want to turn it into 3D. We want to add thickness to this square. So your patch has got a certain thickness. We want to add a certain thickness to it. And we don't want it to be too thin for the patch because if it's too thin, then it won't be strong and it will break. When after it's printed on the printer and you try to remove it, it probably break at that point. So you don't want it to be too thin. We want to make it 1 millimeter minimum. Okay. So how do we add thickness to this thing? You see this icon here? Pad. If you don't know what the icon does, if you put your mouse pointer over the icon and just let the tooltip show up because it tells you what it is. Okay. So we want to pad something to add thickness. Okay. So use the icon, click pad. And then you see it will add by default 1 centimeter or 10 millimeters thickness to the object. You can change that on the left-hand side. At the moment, it says 10 millimeters. We want to reduce that to 1 millimeter. So we type 1 millimeter and click OK. Now you've got a patch that is 15 millimeters across, a square patch, and 1 millimeter thick. Do you follow? Now we're halfway there. We've got we're half done with the model already. Then what's missing? You want to add the microneedles. Okay. So let's say we want to make the microneedles. What I've just done there is I've zoomed into the object. And if you're using a mouse on a desktop computer using a mouse, it is very easy to zoom in. You just use the scroll wheel on the mouse and you will be able to zoom in. Okay. If you position your mouse over the object and you scroll, it will zoom in. It will center on the object, but zoom in on the object. So if you say if your object is here and you put your mouse pointer somewhere down up there on the top left, it will zoom in on where your mouse pointer is. And therefore you will lose focus on your object. Get it? So when you zoom, make sure that you put your mouse pointer over the object and zoom. Okay, to move your object, you use okay, I have to try to do this myself and think actually what I'm doing because all of this is based on muscle memory now. You press Control and right click on the mouse. Yeah, press Control, right click on the mouse and hold and drag. They'll be able to move the object. To zoom in is to use the mouse wheel to zoom. To rotate it, you press Shift and right click. And they'll be able to rotate it around like this. Yeah. So mostly actually I think you're using the right mouse button, but you use Control and Shift to switch between rotate or what we call pan. We move things around left to right, up and down. So rotate and then move it and around. Yeah. Are you lost? Do you still follow?
Yeah.
You still follow? Yeah. It takes a bit of practice to get used to this. Again, like I said, if you think this is too much for you, it's not for you, that is fine. If you're excited about this and you want to try more, by all means do it. So we got the patch. Now we need to add the needles. You need to define where you will need to add the needles. Remember, you're working on a 3D space. Everything, the position matters, right? Because if you say to the software, I want to add some microneedles, it doesn't know where you want to add them. Would you like to add them to this surface here, for the side, or maybe there, or maybe you want to add the needles at the bottom or the top? The software doesn't know, right? So you need to tell it where you want to put that the needles. So I always like to, now the object is out of view, I want to return to the isometric view, and I want to fit everything on the screen. Okay, so those two icons, return to the isometric view, and then fit everything on the screen. You can also use the keyboard shortcut, which is what I use. So you press 0 to return to the isometric view, and then you press VF. So view full. Okay, it will fit everything on the screen. So try again, VF. Yeah, it will fit everything on the screen. So to add the microneedles, we want to add the microneedles on the top surface. So we select the top surface. Make sure it's selected. When it's selected, can notice the bit, the panel on the left changes, right? I click that, that changes. So these are the things you can do on this surface. All right. We want to create a sketch. Let's press create a sketch. Now you return to the 2D space, just like before. Now you can draw a 2D shape. Get it? Yeah. So we don't want to make this too complicated. Let's just draw 4 microneedles. All right. So let's make them conical, and let's arrange them, 4 of them, 1 in each quadrant on this square. So there are 4 of them are centered around the center of the square. Okay. So let's draw the circle. Use the circle tool at the top here. Click that. Put 1 circle here. Another one there. Another one there. Another one there. Okay. Doesn't matter, they're not the same size, because remember, it's parametric, we can define everything. Yeah, just have the rough shape where you want it to be, and then we can define the parameters. Got it? Okay, so we want the microneedles to be the same diameter. Okay, so we want the circles to be the same size. Remember what we did about the square? If we want to make 2 lines the same.
Select the sides and then press E.
Equal, yes, we press E, right? Same thing here. If you click the circumference of the circles, remember, use the control to select multiple. So click the first circle. You want to click the circumference, not the center, right? And then press control, press and hold control, and click the second one, the third one, and the fourth one. Okay, now all 4 circles are selected. You can see that on the left-hand side. Press E, and they'll be the same size. You also notice that every time you define a parameter, you see on the left-hand side here, it says 9 degrees of freedom. Every time you define a parameter, this number will go down. Yeah, because you're putting more constraints on the object you've just drawn. Everybody follow? Okay, good. So now we want to arrange the needles such that they are kind of the same distance from the center and from each other, right? Again, the easiest way I usually use is the symmetry tool. So I want this circle and this, so I click the center of that circle, and I click the center, hold down control, click the center of the other circle, and then I click the line in the middle. This is my line of symmetry, and I press S. it'll be symmetrical. It'll be symmetrical around that line. Okay. I can also do the same with this circle and a circle below it and the horizontal line, and I press S. Is going to make it symmetrical around that line. And finally, if I do that circle and that circle, and I click the dot in the middle, and I say, make it symmetrical, they are all constrained now, right? So if I move one, the other circles will move in order to comply with the constraints. Okay, so you see on the left-hand side here, we've got 3 degrees of freedom. So there are 3 parameters that we still need to define in order to fix everything in place. So what are the 3 constraints? The distance, the horizontal distance between the circles, right? That's one constraint. The vertical distance between the circles, there's another constraint. And the third constraint is the size of the circle, the diameter of the circles. Yeah, so we need to define those things. So how far do we want the needles to be? Let's make this maybe 5 millimeters apart. We obviously you can change these parameters when you make your own designs, right? So in order to make the distance, say the vertical distance between these 2 circles, let's make that 5 millimeters. We click the center of the first circle, hold down Control to select multiple, click the center of the second circle, and then remember I said horizontal distance is L. The keyboard shortcut for horizontal distance is L. For vertical distance is I. Okay, so if you press I, should be able to specify the vertical distance between those 2 circles. Let's press 5, make that 5 millimeters apart. Got that? And then let's define the horizontal distance. We click the center of the first circle, hold down Control, click the center of the second circle. Horizontal distance, keyboard shortcut is L, right? Length. Make that 5 millimeters as well. Now we've got one remaining constraint to define, which is the diameter of the circle. Now the circles are all fixed in position, that you will be able to drag them, they won't move, right? The only thing left to define is the diameter. So you click one of the circles, click the circumference, and then I think the keyboard shortcut is KO. Yeah, it's KO. There is an icon for it actually, it's up here. Let me find it. Which one is it? Constraint diameter KO. It tells you what the keyboard shortcut is. And you see in the menu. Yeah. So you could click that icon and select constraint diameter, or I prefer to use keyboard shortcuts because it's quicker. So KO. So make sure you select that. And that's 5, right? I think I've already done it. KO 5. No, sorry. Not 5. The diameter shouldn't be 5. The diameter should be 0.5, let's say 500 micron. Okay, so let's do that again. Oh, 0.5. That's more like it. Okay. So you see here it says fully constrained. That's everything that we could have done to the circles. We have already defined it fully. Close that. Now return to this isometric view. We want to build up a cone, right, from this. There are other ways to do this. I'm not 100% well versed in this yet. A cone is kind of tricky to me to build. What I can build very easily is cylinders. Okay, to build cylinders, basically what you need to do is basically pad the circles, create thickness, and then we'll have your cylinders, right? So let's do that, and then from there we can get to a cone. So if we pad these circles, you see these cylinders. At the moment, they are 10 millimeters long. We don't want them to be 10 millimeters long. We want them to be maximum 1 millimeter to fit our definition of a microneedle. So let's make them 1 millimeter long. Okay. Has everybody got to that point? Or have you lost?
I've been lost.
Have given up?
I don't want to see what's
Okay. Okay.
I kind of got lost in the examples, but
Okay, right. It's because you didn't position them properly.
yeah.
Okay, but you've got to the steps where it's fine. I will show you how you can remedy that later. You can go back to the previous step and you can define the things you didn't define properly. Okay. And from here, we can actually create a cone because we know the dimensions of the cylinder. We know the diameter is 500 micron or 0.5 mil. The height is 1 mil. What we can do is there's this tool here called chamfer, that one. Okay, chamfer creates a slope. If you select an edge, it will turn the edge into a slope. That's a chamfer tool. So we can select the edge of this circle here and say, turn this into a slope such that it will turn the thing into a cone, right? So I will do that. And then this window shows up. It pops out an error and say, command not done. It's because the default value that it's specified is not suitable. It's exceeded what the size of the circle is. So in order to make the slope fit the cylinder and create a cone, we need to make sure that we need to define the slope such that it slopes down from the center of the circle to the edge of the bottom of that cylinder, right? So the type of chamfer we need is two distances. Okay, we want to be able to define the distance horizontally and the distance vertically. And I always forget which one's which, so let's try. Let's say this is 0.1. This is 0.2. And let's see which one is bigger. Okay, so the 0.2 is the horizontal. We want that to be half the width of the cylinder. The cylinder width is 500 micron or 0.5. So half of that is 0.25. However, if you put 0.25, the program doesn't like it because it can't deal with the fact that this dot is nothing. The dot has to have a size. The middle bit, right? The middle bit has the top part of this cylinder has to have a size. If you specify this width as 0.25, it doesn't like it because then the peak becomes a single dot with no size. It doesn't like it. So instead of saying 0.25, I make it 0.249. Then the software is happy. It can do it. The vertical size should be 0.99. Likewise, in theory, it should be 1 mil, but the software doesn't like it. So I put 0.99. It's just a quirk of how, maybe it's the way that I've done this. Maybe there's a better way to do it. But if you do that, then can you see there's already a cone? Okay. Obviously, I've done it for one. I should have done it for all four, right? Remember I said you could go back and do whatever that you didn't do, correct certain mistakes that you made. You can do that. How do you do that? So you go to your model. Here you got tasks and you got model. You see here's a list of things that you've done in order to get to this point. You could hide this, for example, the chamfer step. If you hide it and you see the eye icon next to it, it's probably a bit small for you to see, but on this list, these are the things you've done. What it says here is that you've drawn on the origin, on the X and Y axis, you've drawn a sketch. And then from the sketch, you've applied padding. Sorry, I don't know why this sketch is there. Do we need that sketch? No, we don't need a sketch. So this sketch is the square. You can rename it just to help yourself know what it is. I will call this the square. And then when you pat it, you get this base, right? And then on that base, you've drawn circles. And then you patted those circles to make your cylinders. Can you follow? Yeah? And then you've done the chamfer to get to your cone. So you can actually, you can go back and retrace your steps and say, okay, this is how it got here. Now, in the chamfer step, I actually forgot to select the other cylinders in order to turn in the cones. Now I can go back and do that. If I double click on chamfer, this window pops up. And on this list, only edge 18, which is that edge, is selected at the moment. I want to select the other edges. What can I do? I go to click preview, select. So if you click preview, it would toggle it to select. If you click select, it would toggle it to preview. You want to select, yes, you want to click it such that it allows you to select the edges. So hold down Control and select the other edges. And click OK. It's weird because this is turned to 0.25. It needs to be 0.49. There you go. Now we have got a microneedle patch. Okay. Right, because we recorded this, all I'm going to do is I'm going to put this online. So you can try this in your own time if you want. Again, decide whether this is for you. If you really, really don't want to do it, fine. If you find this interesting, you want to do it, fine. You can change your own design, right? So once you got to this point, actually, I would say we should probably have saved this from the beginning. So I put this in a new folder and say this is microneedle part demo. Okay, this is a square array for microneedles. Wonderful. So this is my file. And when you get to this stage, you've got your Word document finished. Remember I said this morning, you know, Word document, and then you turn it into a PDF. Your Word document is finished. If this is the design you want to print. I recommend doing a bit more to the design. Like, for example, if you're using this for microneedle biosensing and you've got different needles have got their different functions. So, for example, if each needle would detect a different antigen, then the orientation of the patch is important to you, right? In this case, there's no way to tell which side is which. Like easily, this could be the top, or maybe that one could be the right hand. You know, because in real, when this is a real printed object, there's no way to tell one side from the other three sides. They're all the same. So if the orientation of the object is important to you, I would usually like create a unique corner. Like for example, I click that corner, I would make it round. Like that. So if this is a real microneedle patch, I know this is my reference point. I know which way is oriented all the time. So I would recommend doing that for your designs as well. All right, so that's the Word document finished. Then what do? In the Word document, you will export it into a PDF file. In a CAD drawing, you export it into a STL file. So you go to File and Export. You need to select the object first. So you need to select, just click anywhere on the left click anywhere on the canvas and Control A to select everything. And then go to File and Export. And then you'll be able to export it into a 3MF file is fine, or STL file is also fine. STL, yeah, that's also fine. So either 3MF or STL. So save this. And now I have demo in my folder. That is the STL file. Now the STL file is like the PDF that you cannot edit, right? It's the final document as it should appear. And you open it in a slicer program. And we use Prusa Slicer because this is a slicer made by the same company that makes the printers. So it's just good to have them made by the same company. And then you slice this. This is a different, a different workflow now. So maybe we can have another a separate occasion where we talk about this. But generally speaking, in the slicer software, you can select the printer that you want to slice for. And in this program, for example, like the FDM filament printers this morning, the Mini, if you want to slice this for the Mini, we can. If you change that on the Mini, the build plate will change to reflect what is on the Mini. In this case, we want to slice it for the SL1S speed, and you see the platform will also change, right, to reflect what's on that resin printer. So there are parameters you can change. For the most basic kind of operation, you want to use supports on the build plate only. And you want to print this probably at an angle, right? So you can select rotation here. But also you probably want to print more than one array at a time. So if you want to print like 6 of these in one go, what you can do is you can select copy up here and then paste 5 times to create 6 copies. And then you press that icon there, it will automatically arrange everything in a nice way on the platform for you. And then you want to select all of them. I just press Ctrl-A on my keyboard and then say, I want to rotate these along the y-axis and print at 30 degrees tilt angle. And then you apply support on build plates only. And then slice. It will take a while to build the preview, but this is how it should appear on the build plate. You should have your 6 microneedle arrays with support underneath, tilted at an angle. And if you're happy with that, then you export it into this here, SL1 archive files. So the file extension format is SL1S. It's basically just a zip file. If we put this under printing, microneedle CAD demo, and just keep it in the sim folder. That is the file that you save onto a USB and load onto the printer and select to print. Okay, what's in that file actually, I want to show you. If I right click this and I open it with 7-zip, which is like a archive, like a zip application, open it. It's basically a series of pictures. Sorry. Okay, that's basically it. Any questions? And if you didn't manage to make your microneedle array today, it's fine. Go home and try this again if you want. See how you like it. Yeah. I have to say it's really powerful if you work in an area like this, like what I work in. We have to design these microneedle array patches yourself. It gives you a lot of flexibility to change the design and things like that. But I can understand that you didn't sign up for pharmacy to do this. Okay, so I can forgive you if you think this is not for you. All right. Okay, let's stop sharing. So if you want to have a go, you know, when you go home, give yourself maybe a few days or however long you want to decide. Okay, it's not too difficult, I have to say. Once there's like a fixed workflow actually to this thing. The only difference is what do you do, what parameters do you set at each stage of that drawing. How many needles you put on the, you know, these are the only things that change. Actually, the workflow is pretty much the same. And maybe you want to make the base plate circular rather than square. But in terms of how you actually build that thing, it's pretty much fixed. Okay. All right. I have to leave pretty soon, so but I want to look at the print. So should we go back to the lab and just look at the print and see how we clean up?